Hello and welcome to the lecture on cylindrical coordinates. So, cylindrical as well as spherical coordinates are very useful for solving the problems because it allows us to solve the problems easily because of the symmetry. Like, for example, if we take a conductor, then um, analyzing different quantities or calculating different quantities using cylindrical coordinates could be easier compared to Cartesian coordinates. So, and the important thing is there are many different things that we need to calculate in electromagnetic theory, like for example, divergence or curl or Laplacian or dot product, cross product. So when we have to do all this, we need to understand exactly how we have to apply cylindrical coordinates. So we need to understand how in cylindrical by using cylindrical coordinates how we can apply different mathematical tools and etc. So here let's see how to go about that. So let me take another color. Let me choose this. Now, so this is a section of a cylinder. So here you can see two. Initially, I have written XYZ coordinates, and here also XYZ coordinates, and we have placed cylinder so that we can compare with Cartesian as well as cylindrical coordinates. Cylindrical coordinates, we have rho, phi, and z. Here, rho is the radial distance. It is radial distance. So this is the azimuthal angle phi, and it is always measured from positive x-axis in anti-clockwise direction. One important thing to remember about phi is that it is measured with respect to positive axis in anti-clockwise direction, and z-axis is similar in both Cartesian as well as cylindrical coordinates. So basically, you may consider that as height of the cylinder, etc. Now, if we take this point P, so we can write in terms of Cartesian coordinates using trigonometry. So it is very easy that rho will be is equal to x times cos phi plus y times sin phi. So we have to put I cap and j cap here. So when we add is this one. Now let me take in the using trigonometry. Let me convert the coordinates. So here x is in this direction, y is in this direction, and we have p here. So the p is like this, making an angle of 5. So now we can. So uh, it is a triangle. So we get here in terms of x. So this distance is rho. So x equal to I mean this is x axis and y axis, and this is x. So this is x, which is this distance is and this distance. This one is rho. So based on trigonometry, it is rho cos phi, and this one is y is equal to rho sin phi. So basically opposite side and adjacent side. Now rho will be is equal to under root x square plus y square, and we can calculate phi, which is tan inverse y by x. These are very obvious from what we know. When we are using cylindrical and spherical coordinates, it is important to know how differential length, differential surface, and differential volume are changing. So here we can see a volume in this red color. So this is a differential volume. In cylindrical coordinates, this is the differential volume, this red portion which is there here. Volume. So here we have um, and this length is d rho, and from here to here it is rho, and this angle is d phi, and the height from here to here is dz. It might look bigger, but please understand that it is dz. Just for drawing convenience, I have drawn bigger, but understand that it is small. It is very small, like these. It is in the order of this width only of dz. So now it's like a. It can be approximated to a cuboid, like it has different sizes. One is dz, and this width is d rho. Now the other width, that is the this arc length. This arc length will be rho times d phi, because it is at a distance of rho from the z axis. So it will be rho times d phi. So this length will be rho times d phi. Now differential volume dV in this case will be uh, basically product of the three sides of cuboid. So basically this curve will be approximately, when we consider the differential length, it will be a straight line kind of thing. So that's how we get cuboid when we take a small section from the cylinder of this fashion. So now this will be rho, just writing in rearranging so that it will be dz. This is the differential volume. Now differential surface, this is a scalar, but differential surface is a vector quantity. When we take normal to the, uh, suppose normal to or parallel to z axis. So when we do that, that time it will be. So you can see here. Let me draw again using the other color. Somewhat, I am just for understanding convenience. I am drawing bigger. is dz, and this is d rho, and this is rho d5. Now, when we based on the normal surface, based on the surface that we are considering here. So, for example, along z axis, z cap, ds will be rho d5, rho rho d5 z cap, and along d phi cap. So basically, this is the phi cap direction. At the time, we have to consider the dz and d rho. D, d rho dz phi cap, and if it is towards this rho direction, then it will be rho d phi dz. D phi dz. Here it will be rho cap. So this is the differential surface based on how in which side we are considering the surface direction. So remember that differential surface is a vector because it has a direction. Not only this along z cap, phi cap, rho cap, it can be towards any arbitrary direction, and the direction is represented by unit vector. Here, for simplicity case, how we are considering that we have put using the this phi, along phi cap and rho cap and z cap, we have used this differential surface. Similarly, differential length d L bar. This is also a vector, and so basically it is calculated along each side. So if we are going from one point to another point, we consider along rho and in rho d5 phi cap plus dz z cap. Differential length. And we have already calculated differential volume, which is a scalar quantity. Unlike differential length and surface, which has direction, volume doesn't have any direction. So the volume is simply this. So now we have seen how it varies in this. The dot product. So we have two vectors like this, which is cap plus a5 phi cap. So when we do dot product in this, it's straightforward like same with the cross product. There will not be any change in cross product as well. Suppose A was cap, This is how we use cylindrical coordinates, and also will explain you more how it is employed in other mathematical calculations like divergence and so on. Curl, divergence, we will understand more about how to use the cylindrical coordinates and how the mathematics will come into play. Thank you so much for watching this video, and please subscribe my channel. Apart from these basics, so my goal with this set of lectures is to make everything clear of the concepts from basic to the most advanced level of the concepts, and also present you with very standard questions similar to gate type, like numerical answer type questions, multiple choice, as well as multi-select questions. So you will get a chance to um, attempt these questions. You can pause the video and solve one by yourself, but I will try to make sure to frame very standard questions. So be assured with that. Thank you so much for watching, and please subscribe.